This is the brief on the fundamental physics and maths that govern, well, everything that flows. Think from your own arteries all the way to rocket fuel. So we dove into a whole stack of research here, and it really zeroes in on the core mechanics of fluids. And what we found is that understanding things like energy trade-offs and, these clever mathematical hacks, it's absolutely essential if you want to predict how pretty much any physical system is going to behave. Okay, first up, the geometry penalty. Think of it this way. A pipe size, it acts like a massive wall. There's this thing called a Poiseuille flow, and it shows the flow rate is tied to the pipe's radius, to the fourth power. So what does that mean? It means even a tiny bit of plaque in an artery makes your heart work exponentially harder because the flow is fastest at the center and literally stops at the wall. That's the no-slip condition for you. Second, fluid dynamics is all about forced energy trade-offs. It's not optional. Bernoulli's principle nails this down. The total energy has to stay constant. So if a fluid speeds up, squeezing through a narrow spot, it has to trade some of its pressure for that new speed. And what's driving this? High-pressure areas are literally just pushing fluid into low-pressure areas. That's what causes a stream to bend and scatter. And finally, there's this powerful trick engineers use called decomposition. It's a total game changer. You take a really complex problem, break it into smaller, easy-to-solve pieces, and then just add up the answers. This is how we find the real killer of efficiency in something like a jet engine. It's called stagnation pressure loss, which is just a fancy way of saying energy that's permanently wasted as heat, and that directly cuts down your maximum possible thrust. So mastering these ideas, from flow principles to these math strategies, is how you can predict pretty much everything, from engine performance to your own health.